Hi, I'm Claudio from openPicus and welcome to the first installment of this new video series called openPicus Labs, where we go in depth into how to get things done with the Flyport. Today I have a simple setup with a fan and the Flyport and a nice little interface to switch the fan on and off. This is running just off of the integrated web server on the Flyport and the native browser of any phone on market. Here I have just the fan, the power brick of the fan, which is connected to the mains via a digital relay, which is itself connected to the mains, so keep your hands off the hot wire, and digital connection to the Grove module and the Flyport module itself with the programmer to the computer. Now let's see how I got these things connected together. All you need is what you see here: mini USB programmer, Flyport module, Grove carrier board, Grove relay, and Grove cable. Now, how do we assemble these things together? The Flyport module goes into the J1 connector on the Grove board. And to align the mini USB programmer with the Grove board, we have clear mark sign here and here. So we plug them. Then we take the cable and plug into the digital 2 connector on the Grove board and onto the Grove relay. And we are done. You've seen how to assemble all the pieces together for this project, so let's now concentrate on the code. What I'm going to do is program the Flyport to expose a web page with a big easy button to turn on and off the fan, just as you've seen in the previous part. I will not show the web page code as it is not relevant. You'll find it published with the source code in the wiki, so let's concentrate on the microcontroller source code. So let's fire up the IDE and create a new project, Wi-Fi Grove Nest. I'll just call Smart Fan and put it somewhere. At this point, we have the basic project for the Grove, which doesn't come with a web browser by default, web server, sorry, by default. So I'm going to edit the TCP/IP wizard to configure the Flyport as I need it. So here on the first page, just check the web server and we're done. On the next page, it's the name, the Flyport report, the automatic IP addresses, doesn't matter, so skip it. Here I'm going to input the name of the Wi-Fi network I'm going to connect to. So you just fill in with your Wi-Fi network and click next. Now here you have to set up it according to the security of your Wi-Fi network. I'm using open network, so for me it's open. If you have to input a password, remember that if you check the calculate automatically from passphrase and you enter a textual passphrase like, I don't know, yada blah, then the Flyport will take about 30 seconds to calculate the hash of this password every time it connects to the Wi-Fi network. So it may get really slow. In my case, I have to leave it open and click next right through it. And we are done with the setup. Now let's get to the task Flyport module. Here I'll add the Grove relay right here, like this: void start my relay equals new dig_io out, and this creates a new object called my relay, which is an output, a digital output. And then I'm going to attach it to the Grove board, which I've defined it before, and it's already defined in the project. So attach to board, what is my relay object, where it's the digital 2 output. So now I have digital relay, the Grove relay attached to my board on digital 2, and I will just switch it on and off like this. Set my relay on, let's put a delay here, set my relay off, the task delay. Now this should compile fine. Okay, so now let's program the micro to see what happens. Let's take the serial micro so we can check what's happening. Now it gets an IP and it's switching on and off the relay. So let's reset the microcontroller, eliminate this code which only creates noise, recompile and refresh so we are clean. Okay, so now we are clean, and at this point we have defined the grow relay object and we check that it's working. So we want to change the status of the relay from the web page, but the web page lives in the integrated web server, which has its functions in the HTTP app.c modules. So we want to change the status of the relay from the functions in this module, but the relay is in the task Flyport mode. So how can we do this? This is achieved with a global variable. That's to say, a variable declared outside of any function. In this case, I'll declare it here, and like this, bool relay status equals 0. So it is declared and defined in line. Now, in http app.c, I'm going here, and I'll declare an external bool relay status. This way, every function in the http app.c modules will be able to access the variable relay status, which is declared and defined in taskFlyport.c module. So now, we may think that we have relay status, and we can do something like if relay status set my relay on, else set my relay off. Now, in this case, this may be true, because a relay isn't switched very fast. So with the main cycle in the while one parenthesis, even if it runs very fast, we aren't like to switch the relay any faster than maybe a couple times a second. So this may work. But to understand how these things are done generally, we have to use another approach, an approach more human-like. So how do we humans think? A usual way would be maybe what's the status of the relay variable, it's on or off, then what was its status before, then if it's any different, then it's really changed. To do this, I'm using my memory. What was the status of the variable before? The code doesn't have this, so I have to create this memory. How to do this? With another variable, like here, bool again, relay status old. This way I can bring with me the status of the relay on two variables which must agree, or disagree in this case, to act in a certain way. So instead of using if relay status, I'm going to if relay status is different from relay status old, then relay status old equals relay status, that's to update the status, and if relay status set relay on and set relay off. And that's it. Now what I have achieved is that I have the code to watch out for a change in status. And how this is determined? It's determined by checking there's a difference between an old status and a new status. So I'm sure something's changed and I have to act on the change and so switch the relay. Now it's time to head over to the http app.c to create the web server interactions. First of all, let's analyze how the web server works. I have two aspects on the page. When I click on the page, I want to change the status of the relay. So I have an information going from the page to the web server, and I have images that depict the status of the relay. So I have information going from the web server to the page. This works on two different pathways, which I must create in the http app.c mode. In this case, this means I need a piece of code in the http execute get function, which is the piece of code that acts on the clicks from the page, and a part here which will be called void http print relay status, which will be called when the page refresh the status of the variable. So to refresh the status of the relay, to update the image, the http print relay status function will be called. If you are unsure how all these things work, remember we have two very easy and basic tutorials up on the wiki, so go check them out and come back when you're sure you have all the basics covered. Now the relay status function is the easiest one, so let's get started with this. So here, TCP put string socket HTTPs, and this is to say put a string on the TCP socket, which socket the HTTP socket, and what I'm going to put on this is the value of the relay status as a string. So I can write relay status question mark apex 1 0. This is called an inline ternary operator, and this is just the same as writing if relay status TCP to string socket HTTP 1 else TCP to string socket HTTP 0. It's just the same. It's just a more compact way to write an if statement. So I'll just leave it. It's cleaner. And this part's done. Now let's go cover the HTTP GET function, which is a bit more complex. Here I'm going to define a file name, which would contain the actual file name requested in the URL with which you are accessing the Flyport, like 192.168.1.2/index.htm. That index.htm goes into the file name. Then mpfs get file name cur http.file name 20. This function, which is a microchip standard function with microchip variables, the current HTTP variable contains all the status of the HTTP web server, is something you have to learn by memory. Oh, there's a title here, file name, and just don't delve into it, take it as it is and use it just like this. Then I'm going to check that I'm asking an actual refresh of the status of the relay. How do we achieve this? If you follow the tutorials on the wiki, you know that to send information from the page to the web server, we are using a trick, which is to ask for a certain object, which in turn allows us to know what the web page is asking or doing. Like if memcmp file name relay.cgi, like (9). What this does is check that we are effectively requesting relay CGI from the web page. So if the web page has to tell the Flyport something, it just asks for relay.cgi and appends parameters to the relay CGI request, like something like this. So you can see it written and it would be easier. To actually parse something like this, we have to be sure that we've been in the relay CGI part. So we may have multiple parameters and we would have different file names. I may have a relay CGI, I don't know, light CGI, LED CGI, whatever. With this method, you can separate what you do based on what you've been requested. This way you can parse parameter 1, parameter 2, and whatever is on the URL easily. So let's delete this. Now this is the part that acts on the clicks. So it's the part that changes the status of the relay. So here I have an if relay status, and I'm going to use a debug check like this. Ewert write 1, changing status to off, else change status to on, and this just writes on the debug channel, the serial monitor, what is doing when I click on the page. The actual change of the status happens like this: relay status equals not relay status. I'm just inverting the value of the Boolean variable relay status. And that's it. There's nothing else to do. It just works. When you click, the JavaScript on the page calls relay CGI, thus firing this function, the HTTP exit get, which in turn enters this when it gets to relay CGI and switches the status. On the task Flyport, this changes the relay status variable, which in turn gets checked every time the while cycle loop runs. So if there's a change in the status, the relay will be activated and changed. Okay, we're done here, so I know you're itching to do this yourself. So get the entire project with the source code on the openPicus wiki. If you have any idea or want to comment, just use our forum and follow us on Twitter, and see you next time. Bye!